Warm greetings to everyone. This is Karpagamal E and my teammates are Tabassum Fatima R and Kavya S have done the project on classification of COVID-19 using convolutional neural network Resnet 50, and we are guided by Dr. N. P, Associate Professor of the Department Electronics and Communication Engineering. So now the abstract that we put forth are the main significance of employing chest X-ray image is to recognize and determine if it's COVID or pneumonia. So with the help of these images, it actually plays a very vital role for doctors in order to save the lives of patients. This is even more important in nations where the laboratory kits for testing are not readily available. Deep learning based recognition of COVID-19 using images are based and they are obtained from chest X-ray. So this is what we have proposed now. And also the training and testing purposes, the Resnet 50 and exception network are being employed, which acts as the convolutional neural network. The Resnet 50 consists of 48 layers inclusive of max and average pool. And also we have softmax, which is used as the activation function here in order to predict the multinomial probability distribution. The stochastic gradient descent is employed for maximizing accuracy and also to enhance it. The main objective that we put forth is the critical factors behind the rapid spread of COVID-19 pandemic. It is due to the main lengthy clinical testing time. The main objective that we developed is to test a reliable and diagnostic tool in order to help them to detect COVID-19 features from the chest X-ray images. So for training and testing purposes, the Resnet 50 and exception network is used as convolutional neural network. So the existing system that we are currently using is based on RT-PCR, which is reverse transcript polymerase chain reaction, nucleic acid kit in order to detect the viral nucleic acid. So the RT-PCR is actually a gold standard for COVID-19 analysis. Yes, there are certain influencing factors such as pattern series standardization and also pattern series time. In general, scientific imaging techniques are a powerful and efficient way to diagnose COVID-19. The traditional imaging analysis is based on the experience of medical practitioners. COVID-19 is a novel form of viral disease with unique imaging properties according to a recent study. Typically, a CT or a chest exam will have many slices. An examination by a medical doctor takes around 5 to 15 minutes. One test 5 to 15 minutes for medical specialists to examine. The doctor's intellectual tiredness will be caused by repetitive work. The detection and screening on a large scale are not at all possible. Doctors can investigate the improvement of a patient's condition using subjective judgments which are neither obvious and also quantifiable enough. So we have also included a literature review. So this all is based on the work of automated detection of COVID-19 cases using deep neural network with X-ray images by T. Ostak, M. Tallo, Babulo, Ildrum and Achayacom of BioMed, Volume 121. So they have employed a deep neural network to automate COVID-19 detection. So as a classifier, the darknet model is employed, and also it can be used to help the radiologist validate the initial screening as well as to screen patients directly through cloud. For binary classes, the accuracy is 98.8%, while for multi-class cases, it is 87.2%. And also the work of a survey on deep learning in medical image analysis by Chi Lichen, Tikui, B.J. Pechorindi, Setio, Sion P. Gafuni, Van Jinken, and Sanchez medical image analysis on December 2017. Data on pulmonary nodules, interstitial lung disease, pneumonia, tuberculosis was examined by researchers. COVID-19 and pneumonia disease were diagnosed using posterior anterior chest X-rays by researchers named PGB Mountain Carter. So the proposed system that we put forth is COVID-19 and pneumonia, which are recognized in the suggested method employing convolutional neural network, especially its Resnet 50. The convolutional neural network is capable of identifying COVID-19 with a little pre-processing layers. So the main software requirements are Excel 4-bit operating system, Python idle, and the Python machine learning languages. And also we need hardware requirements like a laptop or a computer is enough for this project. So this is our block diagram. So first, the chest X-ray images are being placed into the pre-processing site. So this pre-processing takes out or carries out the process of processing the images of the sizes that's been required in order to let it into the pre-trained images. So these are then given to the softmax function, which is actually the abstraction function, and then it is led to the classifier. So this classifier classifies it as COVID-19, normal and viral pneumonia. That's what we are going to get it there in the result page. So the input images based on the images of chest X-ray, the set of data can be broadly classified as COVID-19, normal and viral pneumonia. So we have taken the data set of totally 111, 70 and 70 images in it respectively. This data set can be found in the causal source link which is being provided here. And some of the examples of the data set images are also being included here. So now about the pre-processing technique. The images obtained from the causal source have a distinct variety of sizes. Images have been pre-processed with the help of exception network and Resnet 50 with the help of max pool and average pool images. The greatest or the maximum value of the area is written by the max pool as the name suggests, and also the average of the relative average area's values is written via the average pooling. So as a result, they are converted to 254 cross 254 pixels, and then they are shrunk to 128 to 128 pixels in the pre-processing approach. So these all take place with the help of implementation in the Python 3.8. So for the pre-trained images are loaded into the pre-training process in order to construct a model and categorize it into three types. The learning rate, commonly known as epoch. So this function is directly proportional to accuracy. Accuracy improves and losses decrease as the learning rate increases. Activation function, softmax, is a normalization and prediction function for multinomial probability distribution. The optimizer function, SGD, that is stochastic gradient descent, is used to help reduce overall loss and enhance the accuracy. So this epoch function is specifically used for increasing the accuracy. As the epoch value increases, the accuracy too increases, which apparently decreases the loss. So we have this classifier, which main job, as the name suggests, is to classify the images as COVID-19, normal or viral pneumonia based on the count of 26, 20, 20 are considered in the testing phases with the use of pre-trained images respectively. The classifier will determine whether the output is COVID-19, normal or viral pneumonia, which will be presented on the screen. So the implementation part is nothing but the epoch training. So now we are training the epoch. As the value of epoch increases, the accuracy also increases and hence the loss decreases. And we have shown 12 values. And these are the graphical images which clearly and apparently represent that the loss are being decreased when the epoch values increase, which apparently means accuracy is increased. So the expected result is displayed on the screen by displaying the colors of red, green and orange for COVID-19, normal and viral pneumonia respectively. Based on the hazardous level, these colors are being given. With the help of classifier, these results are being displayed. And also with the help of this, our work has achievement of 95% accuracy rate. The detection of normal X-ray image, and finally the detection of viral pneumonia. So the applications of this project is mainly for diagnosis purpose, and also, as I said earlier, it is for rapid detection and early diagnosis. So about the conclusion, I would like to conclude here that in this work, deep learning models of CNN are used in categorizing COVID-19 afflicted individuals using chest X-ray scans with a 95% accuracy with the help of the study. And also in future, CT and MRI scans can also be processed using the same deep learning technology to produce even more accurate and efficient results. Aside, we also have this COVID-19 analysis. This could be improved in future to provide results for a variety of disorders. So we have taken references based on the works of T. Oster, Salo, Ildrum, Balglo, Ildrum, Acharya, automated detection of COVID-19 cases using deep neural network with X-ray images, published on June 2020, and also G. Litchin, T. Cool, B. Bajordi, Gafurian, Van der Laak, Jiniken, and Sanchez, a survey on deep learning in medical image analysis, which is published on December 2017. Thank you. Thank you.